X-rays were discovered by Richter Wilhelm Conrad Roentgen. He noticed the barium planetone cyanide screen fluorescing in his laboratory to generate a cathode rays in a Crookes tube some distance away. As with the invention of incandescent light bulbs, the study of electrical discharge through gases was made possible by the development of improved vacuum technology in the 1850s. Early on, English scientists were investigating the patterns of light and dark that appeared in sealed glass lead tubes. The patterns in these partially evacuated tubes were simulated by a voltage drop between a cathode and an anode. Typically, there is a dark space, called Crookes dark space, then a glow, called negative light, then another dark space, this one called Faraday's, and a final glow of positive light. If the air in the tube was exhausted until the first dark space expanded to fill the entire tube and all glows disappeared, then the rays emitted from the cathode could be investigated. The rays cast shadows and they were deflected by magnetic fields, but appeared to be immune to the effects of the static electric forces. As was to be the characteristic of the new ray physics to come, the physics of cathode rays, X-rays, alpha rays, beta rays, gamma rays, and N rays, the nature of the cathode rays was in dispute, the British favoring a stream of particles, those on the continent preferring to think of them as some sort of disturbance of the ether. The British position and the research program developed by J.J. Thomson at the Cavendish Laboratory to study ionization in the gases would result in the discovery of the electron, but that's a different story. Roentgen, a meticulous and observant experimenter, made the obvious tests on the new X-rays. Were they propagated in straight lines? Were they refracted? Were they reflected? Were they distinct from the cathode rays? What were they? Like the cathode rays, they moved in straight lines. Roentgen was unable to refract them with water and carbon bisulfide and microprisms. Nor could he concentrate the rays with ebonite or glass lenses. With ebonite and aluminum prisms, he noted the possibility of refracted rays on the photographic plate, but could not observe this effect on a fluorescent screen. Testing further, he found that X-rays could be passed freely through thick layers of finely powdered rock salt, electrolytic salt powder, and zinc dust, unlike visible light, which, because of refraction and reflection, is hardly passed at all. He concluded that X-rays were not susceptible to regular refraction or reflection. Roentgen found that the X-rays originate from the bright fluorescence on the tube where the cathode rays strike through glass and spread out. The point of origin of the X-rays moves as the...
Some interesting facts about X-rays are: X-rays were discovered by accident by German scientist William Conrad Roentgen while he was experimenting with vacuum tubes in 1895. X-rays can easily pass through the soft tissues of our body, our bones, due to having dense calcium block the rays, but at the same time, soft tissues like muscle and skin let the rays pass through them. Another important use of X-rays is CAT scans, in which very thin beams are used to get clear image of various body organs. Due to their unknown nature, that's why they were given the name X-rays. And today, X-rays are used in the treatment of various dreadful ailments like cancer, fractures, tumors, and other various diseases by passing intense radiation through the affected part and taking the image.
Some uses of the X-rays are actually some of the most important that we have in the medical field today. Some of them include checking broken bones. For example, if you got hurt in a football game and they didn't know what bone was broken or how it was broken, so they could determine how to heal it, they could use that and scan it and find out what was wrong with it. Another important part of it is inspecting canned goods to make sure our food is healthy and nutritious and nothing's been put in there like poison or some kind of prank where they put beads in there or something like that to make you choke. There's a lot of bad people out there today. Also, a very important use for X-rays is airport security to ensure that there are no weapons being transported between one country and another, or any bombs or explosives or anything like that. Also, to make sure that you're not shoplifting or stealing and putting stuff in your bag, they could use X-rays to find out what's in your bag, and also they can make sure that you don't have anything hidden like inside of your body, like your mouth or something like that, like transporting drugs through various places. So those are some very important uses of the X-rays today. For our problems or our calculations for this project, I have some questions. An X-ray scanning a hand has a wavelength of 47 meters. What is the frequency of the X-ray? The other question is, an X-ray has a frequency of 12 hertz. Determine the wavelength of this X-ray.